Hi. In the recent videos that we've posted, we've gotten a lot of comments about this lab shop that they see in a lot of the videos. And so I thought what I'd do is spend a few minutes tonight and go through a little bit about where we're coming from, as well as give you some teasers about some of the projects that we've got coming up in the near future. To begin with, when we moved from the Midwest about 15 years ago to New England, we moved from a rather large house to a rather small and quaint timber frame home that had a lot of land associated with it. But it did not have enough storage space, it did not have a garage, it did not have a shop or a laboratory. And so what we did is we took a couple of acres, cleared the trees, took the trees to a local lumber mill, had the lumber cut up, stick stacked to dry for about a year, and then it was then milled into the lumber that you see that makes up the inside of this room. With the exception of the particle board and the plywood and the doors, everything that you see in here was obtained from the trees that were harvested from this area, including even the tables that are in this room were made from those very trees. The underlying structure of this building is a timber frame skeleton, and as you can see in the ceiling and some of the walls, the very large posts and beams that make up the structure of the building. And then between them is more conventional stick framing, but done in a somewhat unconventional manner. What we did is we took vertical studs, and they're either 2x8 or 2x10, and we placed them on 12-inch centers. And so the actual distance between the studs is 12 inches, but because the studs were set up to be offset from each other, so that the inner wall and the outer wall do not have a direct contact or direct interaction. This is done pretty frequently in construction and provides an extremely effective method of both sound and thermal insulation, because you don't have a direct path for the transmission of vibration or temperature. And in addition to that, we then sprayed a thin layer of polyurethane expanding foam to provide sealing, and then to save money, we backed that up with more conventional fiberglass bats to provide very good insulation. The roof of the building has an R value of about 100, and so because of that very good insulation, we can heat this building with that small propane furnace that you see in the corner of this room. It just ducts to that side of the wall that you see in front of you, and to this room, as well as a small duct that goes up to the upper floor to warm the entire building. And because of the very good insulation, we can keep this entire building, 5,000 square feet, cool with just 2 window air conditioners, even in the warm part of the summer. Furthermore, because of the very robust structure, we get some very high winds in this valley, up to about 80 miles an hour. There's not a peep, a pop, or a crack. You can't even tell anything is happening outside of here because of the very, very robust structure. Very happy with this building, and I wouldn't change anything about it except possibly make it bigger. The other side of the wall behind the cameraman has the garage space, and the garage consists of 2 very large 1,000-pound doors that are horizontal sliding doors that, when are opened at both ends, you could drive straight through the garage space. But in addition to that, even though that area isn't heated because of the surrounding insulation, it remains relatively warm even in the coldest parts of the winter. The layout beyond in addition to the garage on the other side of that wall, is 2 identical rooms like this, the lab shop, and then an identical room on the other side of that wall that looks the same as this, but was originally set up as just sort of a common room. But with the development of so many of these projects and the expansion of what we've been doing here, we've sort of commandeered that side of the building as well, and we'll show you a little bit about that in a future video. The upstairs area is primarily storage, as well as a large entertainment area where you've got the big screen for projection. And you've seen that in the most recent video that we did on the speaker design. The Projects that we've covered in previous videos include both the very high-powered pulsed dye laser. I love working with this. I haven't had a chance very much in the last couple of months because of, again, all the projects that we're involved in. But we're going to show you this again, and we're going to show you some demonstrations of what this thing can do when we get around to it. In addition, we've got some tanks of gas, both for welding as well as tanks of different types of gases for a lot of the projects that we do that require high pressure or unusual gases. There is a metal cutoff saw here, a drill press, and over here a rather small Bridgeport style mill that I've used over the years to construct pretty much everything that you've seen in all of the videos. It's outfitted with a DRO, which stands for digital readout device, and as you move the mill, this gives you a great way of making measurements and being a little bit more efficient rather than having to measure everything out with a caliper. But what I'm finding is that with the projects getting more complicated and producing more parts, and with my sons coming back into town after leaving college, they have the computer skills that should allow us to move to, say, a CNC type of mill. So we're looking at a Tormac mill to replace this that should make us a lot more time efficient. This is a conventional wood cutting bandsaw, but early on I replaced the motor with a variable speed DC motor. We can slow this way down and also use this for cutting metal as well. In the corner, a 100-year-old South Bend lathe. I've had this lathe for a very long time, and it's amazingly high quality. The precision is very good despite its age. And it's kind of a neat thing to be using a 100-year-old piece of greasy equipment to fabricate little small components that are put in the most sophisticated types of lasers that we build. So it's kind of a neat thing. I'm never going to get rid of this. This is our soldering station, and as you see, it's outfitted with an ESD mat. Reason this is important is in our area and many areas of the world, it gets very dry, and just moving around a room, you can develop some static electricity that if you were to touch delicate electronic components could damage them. And so if you're interested in setting up any kind of a soldering station, it would be a good idea to get one of these. But also I'd get the biggest one you can, because we work here, but when you're sort of in the process on different projects, it's kind of nice to have enough room to put something on a safe place that you can safely touch, even if you have a charge, and not damage it. So very good piece of equipment, and obviously stained from a lot of use. Over here, this is our little lab computer, and you've seen this in previous videos where we've hooked this up to fiber spectrographs. It's also the computer that we've used to record all of our previous videos with the little lapel mic. Very inexpensive mic, and as we saw in the previous video on the speakers, it just doesn't have the quality that we need moving forward. So we went ahead and purchased one of the Audio-Technica Pro 10 systems. You'll see a couple of the microphones here. We're recording with that right now. That should give us a much better audio quality to the videos as we move forward, and when you hear the follow-up on the video for the speakers, you'll really hear how good they sound once you have a really good microphone to record it. This is sort of a table of projects in process, as well as some of the projects that we've already completed, like our smoke devices. And as you continue to move around, you'll see that we have a bunch of little cabinets here that contain wires, tooling for the mill and the lathe, an optical cabinet that contains a lot of lenses and mirrors and filters. We have an electrical supply cabinet here that has all of the wiring that we need for a lot of our projects. Little liquid nitrogen dewar that helps us when we're doing any low temperature work. And a lot of our hardware and screws and fittings are kept in this cabinet here. We probably have just about every size of every single screw, bolt, washer that you can imagine. And this is sort of the go-to drawer for a lot of our projects. And it's nice to have that. The other thing that I want to show you here, back here, if we back up just for a little bit, is this optical table. It's called an optical table because it's manufactured often by optical firms. You can get them on eBay for a very small fraction of their original price. It's probably a $12,000 table. You'll probably pick it up for about $500 or $600. They're not just useful for optics. Because of their milled, very flat surface, they can be used when you're setting up and screwing together components, because you can rely on the very flat surface as a reference point. The stainless steel means that it doesn't rust when you get it wet, and because of the 1/4-20 holes that are drilled and tapped on 1-inch centers, it makes it very easy for you to set up a rapid fixture for some sort of a project you're involved in without having to do a lot of drilling and screwing and fabricating. And then you can just tear things down. So it's a nice thing to have even if you're not doing laser work. So you might also be wondering what we've got in the works. In upcoming videos, we're going to be covering how to make your own thermal adhesives. You can obtain thermal adhesives very easily, but at very high cost. And we're going to show you how to manufacture your own in matrices of polyester, silicone, epoxy, grease, using some unusual compounds that allow you to produce your own adhesive, customize it to your own needs, and manufacture it for maybe 5% of the cost of commercially made thermal adhesives. We'll then characterize them and show you how well they work. I'm also going to show you how we are building a solar cell system that works much more efficiently than the typical setups that are installed all over the place. We'll show you how to make them more efficient as well as low cost, and we'll do some comparisons with existing solar cell systems just to show, you know, what you can do and how you can do that. We're also going to begin a series of videos on jet engines. One jet engine that you do not see on the table right now is already out in the other part of the barn in the garage. And in a few days, we're going to be filming that video on a hybrid jet engine. I think you're going to like it. The video series will also include work with pulse jet engines. This engine, called the Cyclone, is from Robert Maddox at Maddox Jets. And you might want to take a look at his channel because he gives a nice explanation for how these work. We're going to do some pretty significant modifications of this jet to increase its thrust and, more importantly, substantially reduce the fuel consumption of these jet engines. So I think you'll like that one too. We're going to show you how to build a DIY turbojet engine. A very small turbojet or turbocharger is going to be put in the mill, and we're going to take about half the weight off of this to make it much lighter. And after we fabricate this and show you how this works as a typical jet, we're then going to be developing a couple of turbines to allow this jet to actually act as a gas generator for a turbine-powered APU to drive a generator. We're also working on not only a larger version of the APU or generator system that we showed in a couple of videos, we're also working on larger and smaller units. And because, like I said, I'm not the only brain here, and with my sons involved in this, we're going to be able to pick their brains for more sophisticated electrical work. And so one of my sons is working on an electrical system that will allow us to do remote start on these small generators, as well as computer-controlled feedback loops on the jet engine. So these things will become a little bit easier to use and a little bit more reliable. To sort of like summarize where we're going to be going, is that these things are going to be going on over a period of, a couple of months, a couple of weeks, a couple of months. And because obviously these are very complex projects, one of the criticisms I get is that, the room is too clean. You can't be doing real work in here with this room being so clean. Understand that when we produce a video, we obviously pick up the trash and sweep the floor. But with these projects being so involved and often being done simultaneously, it would be chaotic to be working on one project and then doing another project at the same time and having another project at the same time. It would be too difficult to try to do that. So that nature of the way that we do these projects kind of constrains us to be neat. And it also makes it just a little more pleasant to work. When you need a screwdriver, you go to the drawer that has the screwdriver in it. So finally, the last thing I'd like to do is a bit of a shout out to my cameraman. All of these videos have continually improved in quality, both the audio quality, as you're going to see in this video, the video quality in a lot of these videos is improving, the editing is improving. We're learning and we're getting better, and it's that kind of brain power by people that you don't see that really makes what we're doing here a lot easier for you to watch and a lot easier for me to produce. So hopefully this is a good overview of what we're doing here, and like I said, you're going to be seeing some interesting videos coming up in the near future. So I really appreciate your watching. I really would appreciate it if you'd subscribe, because it really helps us out. And I wish you a very good evening. Good night.